Okay, today I want to talk to you about reflection and refraction. Here's a great example of each. Here's a light source that is shining from air onto the surface of water. You'll see that some of the light reflects off the surface and some of the light goes into the surface. You'll notice that the light that bounces off of the surface leaves at the same angle it came in. So we measure our angle from the normal line. So it's coming in at a 60-degree angle and it's bouncing off at a 60-degree angle. That is always true for reflection. The angle of reflection is the same as the angle of incidence. You'll notice that the angle it's bending to is much less than the original angle. So instead of coming straight through at the 60, it's more like a 40-degree angle. And you'll see that angle will change as I change the angle of incidence. But when you're going from something like air to water, you'll notice that the angle is always less for refraction than it is for incidence. Now if we start in the water, so we put the water as our top source, and we go into the air, you'll now see that the situation is reversed. You'll now see that the angle of refraction is bigger than the angle of incident. When you hit a certain angle, in this case around 50 degrees, the angle of refraction becomes so big that it no longer refracts. This is known as total internal reflection, and the angle at which this happens for the first time is called your critical angle. Okay, so summarizing mathematically, here is the picture of refraction. Light comes in at a certain angle. When it switches mediums, it bends to a new angle, and we can find these angles using Snell's law, which is angle of incidence times, the index of refraction times the sine of the angle of incidence is equal to the index of refraction you're going into times the angle of refraction. Remember, for critical angle, the angle of refraction will be 90 degrees.